Hey everybody, Vade here, and today we're just going to be finishing up the rest of our inverse trig derivatives. So that is the derivative cosecant inverse of x, secant inverse of x, and cotangent inverse of x. For this video, I'm just going to use similar logic to the last video, except I'm not really going to just draw triangles. I'm just going to use our Pythagorean identities just to simplify it a little bit. So anyway, let's get started here with the derivative of cosecant inverse of x. I'm going to let y equal to cosecant inverse of x. So just a few things to recall from last video. Firstly, if I say arc cosecant of x, or arcsecant of x, or arccotangent of x, that's the same as cosecant inverse of x, secant inverse of x, and cotangent inverse of x. Okay, and secondly, remember if we do f of the inverse, that the inverse and the function will cancel, and the converse is also true. So what I mean by that is if we do the cosecant of both sides, the cosecant here and its inverse will cancel. So we'll just get cosecant of y equals to x. Great. So now what I'm going to do here is I am going to take the derivative with respect to x of both sides, ddx just like last video. So derivative of cosecant, hopefully you know that's negative cosecant cotangent. If you do not know how I got that, watch the video I made, I think 2 videos ago, which goes over the proving the rest of the trig derivatives. Because think about it, why would I go to the inverse trig derivatives without proving all the fundamental trig derivatives first? Anyway, so then this should be negative cosecant y cotangent y times dy dx equals to 1. We want to isolate dy dx on both sides by dividing by cosecant y cotangent y on both sides. So then these two will cancel here, and we are left with dy dx equals to 1 over, and this should be negative, by the way, negative cosecant y cotangent y. Okay, so what do we do from here? Well, we want to think a little bit about our Pythagorean identities. Okay, so if you recall, and again, I made a video about this in the Understanding Not Memorizing series, 1 plus cotangent squared, and we're going to just use y here, will have to equal to cosecant squared of y. Okay, if you're confused on how I got that, watch the video I made like a while ago, which goes over all 3 Pythagorean identities. So what we want to do here is we want to isolate cotangent squared of y. Why? Because we want to get the denominator in terms of cosecant. Or want to get the denominator in terms of cosecant. So what I'm going to do is I'm going to just get cotangent, or I'm going to use a different color here. I'm going to use green here still. We'll get cotangent squared of y equals cosecant squared of y minus 1. Now, we just want to take the square root of both sides. And we'll get cotangent of y equals to the square root of cosecant squared of y minus 1. Remember, no plus or minus here. So now we can substitute this cotangent of y with square root of cosecant squared of y minus 1. So then we'll get 1 over negative cosecant of y square root of cosecant squared of y minus 1. So now, thinking about this here, I'm going to rewrite this. I'm going to use a purple marker here. We have cosecant of y equals x. So cosecant of y equals x. We see a cosecant of y here, and we see a cosecant of y here. So why don't we rewrite this as 1 over negative x square root of cosecant squared of y minus 1. Well, we still have a cosecant thing here as well, so why don't we just square both sides to get it to cosecant squared? So then we'll get cosecant, I'm just going to stick the same color here, we'll get cosecant squared of y equals x squared. Okay, so then we'll get 1 over negative x square root of x squared minus 1. So we can say Therefore, 1 over, or um, dy dx has to equal to 1 over negative x square root of x squared minus 1. Now, I'm going to write a note here. And this note will apply to all of to some of the other I think it would be the secant one. That's the other one where this note would apply to. I'm going to say note. Sometimes this is written as 1 negative 1. I think negative 1. Let me check here. It should, if I did it correctly here. I know I'm searching up inverse trig derivatives just to make sure I did it correctly here. They sometimes write it as negative. Give me 1 second. They sometimes write it as negative. Crap. What am I doing here? They sometimes. Yes. They sometimes write it as negative 1 over absolute value of x square root of x squared minus 1. They sometimes write it like this. Now, I think this is because of the domain restriction that applies. But since we're not like dealing with equations relating to this or anything like that, I would stick to this for now. But the real correct answer is this. And I'm not going to go into detail with that, but just think about domain restrictions. And this, I think, note applies to the secant inverse, or secant inverse of x derivative as well. So just be careful about that. Just be mindful of that absolute value. Anyway, let's move on to the next inverse trig derivatives, which is secant. So let's let here y equal to secant inverse of x, right? So if y equals to secant inverse of x, I want to cancel out the inverse, so I'm going to do secant both sides. Should cancel here, and I get secant of y equals x. Okay, secant of y equals x. Take the derivative with respect to x of both sides, and we get secant. Derivative of secant is secant tangent, right? Secant x or secant y, tangent y dy dx. If you do not know how I got that, again, watch the video I made 2 videos ago, which goes over how to get these derivatives. So dy dx equals to 1. We want to isolate dy dx, so we divide by secant y tangent of y on both sides. And then these cancel here, and we get dy dx equals to 1 over secant y tangent y. Do you notice something here? Do you notice a trigonometric or a Pythagorean identity, just to make it easier on you? A Pythagorean identity which relates these two? Well, I do. That's just 1 plus tangent squared of y equals secant squared of y, right? Again, if you're confused, watch one of my videos which goes over Pythagorean identities, how to prove them. So in this case, I want to get this in terms of secant squared of y. Or, in terms of secant squared of y. So I'm going to isolate tangent squared of y equals to secant squared of y minus 1. I want to take the square root of both sides, and I get tangent of y equals to the square root of secant squared of y minus 1. So now we can substitute here 1 over, and again, we can go to that next. Square root of secant squared of y minus 1. So now, going back to this relationship here, secant of y equals x. I'm going to write that, draw an arrow here. right? We have secant of y equals x. I see a secant of y here, so this should be 1 over x square root of secant squared of y minus 1. Just square both sides here, and I get secant squared of y equals x squared. So then we can substitute this for this. So then we'll get 1 over x square root of x squared minus 1. So we can say, therefore, dy dx equals to 1 over x squared root of x squared minus 1. Again, can be written as 1 over absolute value of x squared of x squared minus 1. Depends on, I would say, the context. I mean, you should be safe with the absolute value, but I would say for the sake of my series, I'm not really going to go into that whole thing for now. Who knows, maybe in the future. Okay, so now down to our last inverse trig derivative, and just trig derivative in general, I guess, which should be y equals to cotangent inverse of x. So what we're going to do here, take the derivative with respect to x of both sides. Or no, actually no, not yet. Why would I do that? Because if I did that, then I would have to know the derivative of cotangent inverse of x. What the heck was I just doing? No, take cotangent of both sides. These two will cancel, and we get cotangent. I'm going to use black here. Cotangent y equals x. Okay, now we take the derivative with respect to x of both sides, and we get, again, cotangent derivative. You should know this. Watch the previous video if you don't. Negative cosecant squared of y times dy dx equals to 1. If you're really having trouble remembering these, by the way, remember that the co-derivatives, the co-sounding derivatives, always are negative. Let me look here. Does this apply with the inverse trig? I think it does. Okay, I think it works for the inverse trig as well. But again, that requires a little bit more. Like if you're trying to remember these, oh yeah, it should. So your co-inverse trig derivatives as well. Yeah, your co-inverse trig derivatives as well should be negative. So yeah, anyway, we want to isolate dy dx on both sides by dividing by negative cosecant squared of y. These cancel here, and we get dy dx equals 1 over negative cosecant squared of y. Okay, so this is, I would say, well, yeah, we should still use a trig identity here. Well, we have a cotangent here. Okay, we have a cotangent here. We have a cosecant here. What relates cotangent? Which Pythagorean identity relates cotangent and cosecant? Well, that's 1 plus cotangent squared of y equals cosecant squared of y. We want to turn this cosecant into the cotangent. So we just square root. We just square root. Oh, actually no. We are trying to get this in terms of literally cosecant squared of y. So literally, it's just negative of this. Sorry about that. Negative of this. Again, I keep in mind, I don't memorize these proofs. Like, I'm just doing it as we go. That's why I had to check a few minutes ago. Like, oh wait, am I doing this correctly? Like, no, I don't have these proofs necessarily memorized. I'm just going with the flow here. Okay, I'm just like seeing what works. Okay. So, but of course, like I do have the derivatives, like I memorized, but I know where they come from. So I'd say it's more like I'm just remembering them for quick reference, sort of thing here. So this should then be negative 1 minus cotangent squared of y equals to negative cosecant squared of y here. and then or we could just add the negatives. Will the negatives cancel? Let me see. Would the negatives cancel? This should be I don't know. I'm thinking. This should be, yeah, negative cosecant squared of y. I'm just gonna write the negative up here. Cosecant squared of y. I don't know why it's messing with my head here. Yeah. Yeah. We could just forget about this, and since it's just negative 1 over cosecant squared of y, it would just be same thing as negative 1 over 1 plus cotangent squared of y. Yeah, that makes sense. So then now we see a cotangent squared of y here. Well, what relationship do we already have? Well, we have cotangent of y, and I'm going to draw the arrow here again, the infamous purple arrow. We have cotangent of y equals x. We want to find cotangent squared of y. Well, we're just going to square both sides, and we get cotangent squared of y equals x squared. So we get negative 1 over 1 plus x squared. So we can say then, therefore, dy dx equals to negative 1 over 1 plus x squared. So yeah, there we go. These are all of our, the rest of our inverse trig derivatives. Sorry I was a little stuck there for some of the proofs. This just shows that, like, I don't memorize the proofs. Some proofs I do memorize, more of like it's a habit to prove these, but it's not a habit for me to prove a lot of these things. But it's really my mission to do so because of, students, they hate memorizing. They love knowing where these things come from, and teachers often fail to do that because of time, because of laziness, whatever it is. Hopefully it's not laziness. There are a lot of good teachers out there. I'm sure it's probably for time sake or lack of interest. But I still think that it's very important to know where these come from. These come from relationships we've already defined. And again, if you don't know where I got this, like, oh, derivative of cotangent of y is negative cosecant squared of y dy dx and all this kind of stuff, like, please watch my previous videos, right? Because then I proved those relationships as well. I even proved these Pythagorean identities, like all of the stuff. Like I go from the ground up here. Okay, now there are some things that I've not done yet at the time recording. I haven't proved the unit circle, sum and difference identity, stuff like that. I've not done those yet, but I do plan to do those. So if you're watching this like 10 years from now, you should see those hopefully already there. But yeah, please, I want you guys to understand these relationships. Anyway, sorry for the long video. Sorry for a little bit of the confusion. I'll see you guys in the next one.